Well, here we go. Last video for section 3.2. We're on example number 7, which is on page 14 of your note packet there. And today we're just going to talk briefly about logistic functions and how you do some solving with those. I'm also going to do one of the examples from your homework packet. So you do need to get that out as well, because there is not really an example like some of those in your homework packet. So I want to make sure we go over one of those. All right, so let's jump in here to example number 7. We've got this function right here, which is modeling the number of students who have heard a rumor. It says Surfside High School has 1,500 students. Max, Patty, Juan, and Andrea start a rumor which spreads logistically so that this is the number of students who have heard the rumor by the end of T days, where T equals 0 is the day the rumor begins. So first question is then just how many students have heard the rumor by the end of day 0. Now notice that T is the number of days. So if we're on day 0, we just need to put in 0 for T. So we just basically need to find S of 0, which is 1,500 over 1 plus 38 times e to the negative 0.9 times 0. Now, of course, negative 0.9 times 0 is 0, and e to the 0 is 1. So really, we just have 1,500 over 1 plus 38, which is 1,500 over 39, which is, I believe it's approximately 38. Let me check that real quick. Let's see, let me get out of here. 1,500 divided by 39. Yeah, it's about 38 students, and so that would be then your answer here. Oops. All right, so that's how you do part A. Now, in part B, it is asking, how long does it take for 1,000 students to hear the rumor? So the number of students is what you would put in for S. So really, we're wanting to put in 1,000 for S here and then solve for T. I think I would just prefer to solve these graphically, to tell you the truth, and that's what I've got going on here on this next slide. So I graphed the basic function, the y equals 1,200 over 1 plus, that says 39. It's supposed to be 38. So this graph is not going to be right. Let's go over to the calculator and get the right one in there. So for our y1, I'm going to graph 1,500 over 1 plus 38 times e raised to the negative 0.9 x power. And then I also want to graph y2 equals 1,000. I'm just looking for the intersection of those. I want to know when is the number of students who have heard it 1,000. On the window, you need to think about this a little bit. Remember, your T values are the number of days it has been. So it's going to be more than 0 days. And I don't know how many days you think we should go out, but I think the rumor is going to spread pretty fast. So I definitely don't want 200 days. That's more than a full school year. Let's just do, I don't know, 30 days. Let's see how much it spreads in just 1 month. And then on the y, that represents the number of students who've heard the rumor. So it's going to be greater than 0. And the y max, remember that in your function over here, this number in the numerator here, That's the limit to growth. So that is as many students as can hear it. And that's because there are only 1,500 students in the whole school. So we know that our maximum here is just going to be 1,500. I'll scale that by 100. Now let's graph and see what that looks like. So in the blue here, you see the logistic function. It's that famous S curve. This is, on each day, how many students have heard the rumor. Let's see where this intersection is here. And that will tell us. So it looks like they intersect at x equals about 4.8. So in about 4.8 days, or maybe you would round it up to 5 days, that would give you 1,000 students would have heard the rumor. So let's put that in here. Yeah, this had 5.8, but that's because this equation was wrong. So the real answer should be, what did we say? 4.8 days. Or you can do approximately 5 days. Okay, again, we'll just totally ignore this. All right, so that's that one. Now, the next thing I would like to do is go to our notes packet, not our notes packet, our homework packet, and look at problem number 9 in the section 3.2 homework. I think that's on page 5. So 9, 10, and 11, 9, 10, 11, and 12 are going to be done in the same way. So I'll just do number 9 together, and then you can do 10, 11, and 12. So on number 9, it says you have an initial value of 28, a limit to growth of 62, and it passes through the point 1, 36. It's a logistic function, it says, up above there. So the basic form that we're going to use is this one. Now, the easiest number to fill in to begin with is that limit to growth. They tell us right away that that's 62. Remember, that's the numerator. That's that C value. The other thing they tell us is that the initial value is 28. So that means when x is 0, when no time has passed, f of x is 28. So I can put in 28 for f of x and 0 in for x. But I know that anything to the 0 is 1, so really this b to the 0 here, that's just equal to 1. So a times 1 is just a. And now I can easily solve for a, multiply both sides by 1 plus a. Divide by 28. And then subtract 1. So a is going to be 62 over 28 minus 1. And that turns out to be, I got a fraction there of 17/14. You may want to leave it in fraction form, or in some cases you may want to just find a decimal approximation. Whichever way you want to do it is fine. I'll just leave mine in fraction. Then the other piece of information that they give us is the fact that it goes through the point 1, 36. So what we know now is we know C is 62, and then we just found out that A was 17/14. And now the other piece of information is that it goes through the point 1, 36. So what you're going to do is just fill in 1 for this x value and 36 for this f of x value, and then you're just solving for b there for the very last step. So, just go through and do the algebra. I would probably divide by 36 here. And then subtract 1. And then multiply by 14/17. So B is going to be 14/17 times 62/36 minus 1. Again, decimals are okay here. I'm just doing fractions. I got this to be 91 over 153. Or as a fraction, it's about 0.59. So now we have A, B, and C. That's what you're looking for here. You are trying to find what are A, B, and C that you can put into this function. So now I can write the function out. I'm going to put the C value 62 in here. The A is 17/14, and then the B, what we just found, is that 91 over 153. So your final answer is f of x equals 62 over 1 plus 17/14 times 91 over 153 to the x power. And that's what you're looking for. It said, write a logistic function that satisfies the given equations, and there it is. So you are finding A, B, and C. That concludes the notes for section 3.2. So you should be able to finish the rest of the problems from that section in your packet. So do numbers 10, 11, and 12, and also do number 14. We're going to skip number 16, so don't worry about that one. And if you do those other ones, you should be fine. Also, please keep in mind that throughout this, you can always refer back to your textbook. These lessons, although we're not doing problems from the textbook, we're doing them in these packets, but they follow right along with the book sections. So if you want more help on any of these, feel free to look at that. All right, hope you all have a great day. See you later.